Force analysis is an inherent part of every engineering marvel, from Starship to the kitchen knife. This video will explain system of forces with real-life applications, types of supports, and design a free body diagram to solve force system. To understand this, imagine three-dimensional world with x, y, and z axis, as well as three planes xy, yz, and zx planes. Planar forces act in a single plane, which can be a single line, collinear forces, or not in the single line, non-collinear forces. On the other hand, non-coplanar forces pass through many planes. Most real-world structures are examples of the non-coplanar forces. When forces meet at a single point, they are referred to as concurrent forces, and opposite non-concurrent forces. Two opposite forces are at work when Starship lifts off its position. The thrust force pulls the ship upward, while the weight of the ship acts downward. These forces are referred to as collinear forces, as they are in the single line. We can determine the force needed to raise a Starship using a collinear force system. Forces acting in a single line but opposite to each other cancels each other out. The weight of spacecraft due to Earth's gravity is the force applied on it while it is stationary. Weight is equal to mass into acceleration due to gravity. In order to lift Starship, the thrust force should be greater than its weight. The spacecraft then has the ability to lift from its place. Forces acting in the same direction, however, we add up to the greater net force. Tug-of-war is a classic example of this. Lifting and moving weight from one position to another using jeep cranes. Cranes that are carrying weight at any given moment experience force and stress from its weight on all of their structural components. These components should therefore be strong enough to support weights. There are forces acting on a single plane in crane, and the line of action intersect at a single point. The forces in the system are coplanar, concurrent, non-collinear forces. Lami is used to determine the value of forces in each member. When three forces act on the body in equilibrium, the three sides of triangle represent these forces. Every force has a direct relationship with a sine of angle formed by two other forces. In this way, we can determine the force acting on the tie rod and jeep crane. Coplanar forces are exemplified by an airplane with two thrusters or jet engine running in parallel. As a result, the net force acting on the object will increase. Let's now examine forces that are not in a single plane. Wire ropes are used to stabilize portable mobile towers. Its position will be disturbed by wind load. These ropes are anchored in the ground, and their tension is adjusted based on the tower's deflection and wind force. These ropes pass through several planes before coming together at a single location on the tower. Non-coplanar concurrent forces is the name given to this force system. This system can be used to calculate the tension force in each rope. Supports. There are no relative movement in fixed supports. They stop movement that in both translational and rotational. The ideal illustration of fixed support is a beam that is anchored in a wall, while fixed supports have three forces at the joints: normal force, reaction force, and movement force. Bridge structures have pin supports as numerous joints. As a result, the structure can rotate but cannot translate either a vertical or horizontal direction. Both vertical and horizontal reaction forces are provided by these. Bridge positions are slightly adjusted by large bridge pin supports under high wind loads. Materials such as steel expand at high temperature and contract at low temperature. These environmental factors are having a greater effect on long-span bridges. As a result, bridges must also be adjusted axially along their length. Roller supports are used at this location. Sometimes roller supports are a mix of rollers and pin supports. As a result, structure can move slightly along its axis and also rotate. There is only one reaction force provided by this, that is vertically upward. Bridges can expand lengthwise and longitudinally without experiencing stress or external damage. Thanks to these supports,